Good morning, student. Today I am going to teach you carbon and its compound. Okay. So, at first, carbon. It means its symbol is C. You are knowing. Atomic number and mass number of carbon is 6 and 12. Isotopes of carbon. What is isotopes? The element having same atomic number but different mass number, that is called isotopes. Symbol is C, atomic number is 6, mass number is 12. Now, carbon is compound chapter. Number one question arises here, carbon forms maximum number of compound Y. This is a big question. Carbon forms maximum number of compound due to presence of two properties. One is called catenation, another is tetravalency. Okay. So, carbon atomic number is 6. So, this is the electronic configuration of carbon. This is the electronic configuration of carbon in case of orbit, but in case of orbital 1s2, 2s2, 2p2. Okay. So, as far as the concern of valence electron, the electron present in outermost orbit, that is called valence electron. So, valence electron of carbon is 4, valency is also 4, that is why it is called tetravalency. Now, at first I am just going to calculate the position of carbon in modern periodic table. You know that position of carbon in modern periodic table is totally based on electronic configurations. So, this is electronic configurations. With the help of electronic configuration, we are able to know the valence electron. So, valence electron is 4, that is why group is 4. Last electron enters into p orbital, so its block is p, and you know that its block is either S or P, they belongs to subgroup A, or in case of DF belongs to subgroup B. So, 4A, it means it is called 14, and period equal to number of orbits. So, number of orbit is 2, that is why they belongs to period 2. This is the one way. Another way for calculating period, whatever the number is multiplied with the help of block, that is indicates period. So, altogether you can say that carbon forms, carbon belongs to group 4A or 14, block P, period 2 in the modern periodic table. But I have already told you carbon forms maximum number of compound. This is due to catenation and tetravalency. So, my question is, what do you mean by catenation? Catenation means carbon has ability to form long chain by self-linking. Okay, to form long chain by self-linking. So, self-linking properties of carbon is called catenation. And self-linking, it may be straight, it may be branch, or cyclic. Okay, this is the such properties of carbon is called catenation. Now, another important things, that is hydrocarbon. It is clear from its name, hydrocarbon. Hydrocarbon, compound formed by hydrogen and carbon. It is a compound of hydrogen and carbon, that is called hydrocarbon. You know that hydrocarbon are two types, saturated and unsaturated. In case of saturated hydrocarbon, only one part is called alkane. Now, it has two, which is alkene and alkyne. Okay. So saturated hydrocarbon, the hydrocarbon which is satisfied by single covalent bond, that is called saturated hydrocarbon. You know that covalent bond, the bond formed between two atoms by the sharing of electron. Already discussed these things. Sharing of electron, that is called covalent bond. If sharing is a pair of electron, then we can say single covalent bond. Is if it is shared by two pair of electron, double, three pair of electron, that is triple. So in case of alkane, it is satisfied by single covalent bond. It means general formula is CnH2n plus 2, where n is the number of carbon atoms. N is the number of carbon atoms, 1, 2, 3, 4, etc. In case of alkane, methane, ethane, propane, butane, okay, n is equal to 1, 2, 3 and 4. Now put the value of n, we will get formula methane, this is ethane, propane and butane and so on. So this belongs to alkane group. Now in the similarly the general formula of alkene is CnH2n and alkyne is CnH2n minus 2. But n started from 2, 3, 4 in both cases. Reason is that for double or triple covalent bond at least 2 carbon is required. So it is started from 2, 3, 4. Now let us understand one by one. Alkene. In case of alkene, ethene, propene, butene. Okay, so n equal to 2, 3, 4. Now put the value in this formula. We will get C2H4 just double, C3H6 and C4H8. In case of alkyne, ethyne, propyne, butane. So n equal to 2, so C2H2, 3, C3H4 and C4H6. So this is the way for calculating molecular formula of saturated and unsaturated hydrocarbon. Now, the one more important term here, homologous series. Homologous series. So what is homologous series? The difference between two continuous hydrocarbon is CH2. Regarding methane and ethane, difference is CH2, ethane and propane. CH2 consecutive hydrocarbon, whether it is saturated or unsaturated doesn't matter. Okay, and the molecular weight difference by 14. Molecular weight difference by 14. In this way, series is formed. This is called homologous series. So methane have molecular weight 16, while ethane have 30, and difference is 14. Okay, and same thing is applied in case of alkene and alkyne also. So this is the homologous series. Now try to understand the structure. This is the structure of methane. This is the structure of ethane. Now propane, okay. So if you want to draw the electron dot structure, then put the electron here in dot form. This is the electron dot structure. If you want to calculate the number of covalent bonds present in saturated or unsaturated hydrocarbons, there is two ways. I have already informed you. One, at first you draw the structure, and after writing a structure, just count the number of covalent bonds. The number of covalent bond is 4. Number of covalent bond 1, 2, 3, 4, 5, 6, 7 in case of ethane, but in case of propane 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this is the way for calculating or counting the number of covalent bond. But one more tricks. Okay, one more tricks here. If you want to calculate the number of covalent bond without drawing a structure of saturated or saturated hydrocarbon, then there is only one way, that is total valence electron by 2. Total valence electron by 2. So how many valence electron present in methane? I mean to say carbon and hydrogen. Carbon have 4 valence electron, hydrogen have 1. So 4 and 1 4 ja 4. 1 to 4 4, 4 4 8. 8 by 2 it is 4. So 4 covalent bond is here. In case of ethane, 4 to the 8 and 6 14. 14 by 2 means 7. In the similar manner, 20 in case of propane, so 20 by 2 it is 10. So this is another way for calculating number of covalent bond. Now this thing is applied in case of alkene alkyne also. Now take one more example in case of alkene. This is the structure of alkene. Okay, but how many covalent bonds? 2 to 4 to 6. 6 covalent bond is here. Otherwise 4 to the 8, 8 and 4 12, 12 by 2, that is 6. In case of ethyne, this is the structure of ethyne because triple covalent bond between the carbon atoms and number of covalent bond is 4, 3, 1, 4, 1, 5. And total valence electron 4 to the 8 to 10, 10 by 2 equal to 5. So this is a way for calculating number of covalent bond. Now one more things, with the help of molecular weight, how can we calculate the molecular formula of saturated or unsaturated hydrocarbon? So molecular weight of, I am just taking example hexane. This is a hexane, and you know that its molecular weight is 12 into 6 plus 1 into 14, 72 plus 14 equal to 86 unit. This is the molecular weight. With the help of this molecular weight, how can you calculate the molecular formula? You are doing. I am just going to express. And now same things apply in case of alkene alkyne, but general formula is different. So general formula of alkane is CnH2n plus 2 is equal to the 86. So what is the molar mass of carbon? Atomic mass, I mean 12. So 12n plus 2n plus 2 equal to 86. So 14n plus 2 equal to 86. 14n equal to 84, n equal to 84 by 14 equal to 6. Now put the value of 6 in this formula, then we will get C6 at 40. So this is a way for calculating molecular formula. Now thank you. We will continue on next class again.